I don't know what's happened that it went offline. Um, Let me move this from here. I was talking without know that I was offline. So let me try to organize a little bit here. So I finally was able to open the glitter. Um, let me clean this mess. Sorry about that. I don't want this mess here. Um, where is here is and my alcohol. So I'm gonna show you now the glitter open and show you what you need to do. All right, I'm back. I finally was able to open. It doesn't have a screw. The problem was that this corner was getting caught with this part. So how do you remove the rest of the glitter? First of all, we need to remove these screws. And for do that, I'm gonna use my Fantic. You know, guys, I love my Fantic. Let me use the smaller one. Nah. Let me use the smaller one. I guess this is what, yeah. It's this one, probably. That screw, this other one. There is one screw, to let you know, that have an insulation. And I will show you which one is the one. Neither one have, except the one that I'm gonna show you. That's how you change the board. I ain't gonna open this because anyway, I know this board is not good. It's not charging, right? I removed those screws. This now slide to the outside, okay? So you need to put these cables here and then you slide this just like that. See? You see the pins here? Those pins are these pins that are here. Let me show you. See, you need to, when you put it back, you need to align that. It's not that easy. You need to align it and then slide it back. All right. Now, this is the board, the PCB, basically, from the glitter, egg 11, and this part, to change the PCB, you need to remove the welding from these pins, these four. See these cables. So from the board, and there's another one that you need to remove, and it's this cable, and it goes to one of the MOSFET legs, which is a left leg. If you notice, let me put it here. You see the leg? That's where it goes, to the left one. Let me put it like this. It goes there. So that one have to be removed in order to remove the full PCB from the egg 11. So when you buy the PCB, it came both. It came the MOSFET. This is the MOSFET from the welder, and it came with the display PCB, both of them. So these cables stay, which is the capacitor, and in the back, this is the assembly for the capacitors. Now, some people doesn't know how do you discharge the glitter's capacitor before you weld. Before you open this. Well, guess what? You put it upside down like this, and then you're gonna have a red light when it's fully charged. It's gonna turn on a red light, and when you put it like that and the light goes off, then the capacitor is discharged. That's how you discharge the capacitor. It have like a connector here. See, you feel that it's loose, but it's not. It's in purpose like that. So that make a like an internal connection that discharge the capacitor somehow. All right, now the one that I'm talking about, you remember I mentioned the glitter have only one screw that most to that have the is insulated. Is that one? It's important when you disassemble the glitter, put back that insulation in that screw. It's the only one that have that. Check the other ones. So the other one doesn't matter. It's that one, the one that have to be insulated. If you don't put that, you're gonna blow the board. All right. So my case, I need to change this PCB too. This is this is what upset me from glitter. This PCB have there probably only 3 months, brand new, and I put it brand new, and now it's not charging more than 5.3 volts. It's a problem. So I need to call now, explain. I can get a PCB easy. I mean, that's no problem from me because they know me. And again, I mean, I have no problem from them with glitter. My problem is when somebody else have problems. They really cry their warranty, unfortunately. And you know, the people that are looking at me, they know what I'm talking about. They really, you really need to fight them. They ask for videos. I mean, it's okay if they need to prove something, but hey, don't push too much. I mean, I guess with one, you know, one evidence is enough. The product is under warranty in that year. Give the warranty. I mean, don't cry too much. This is what I explained to the people from the AWID that I really want to help them. If the product is okay, I mean, we have problem with the product, I expect you to give me warranty. That's what I was talking with them, and they promise that they're gonna do it. They're gonna support me. I like the fact that they have a bunch of different models, and I mean, unfortunately, I guess the P120. I'm receiving another one for myself. That's gonna be for me. It's a very expensive product, so I really want to test that model very extensive to make sure. Actually, they inform me they have a new cables than the one that I was using the first time. They have an upgrade cables, and they are sending me those cables. I'm gonna be testing very extensive. If it's a piece of junk, I'm gonna say it. It's a piece of junk. I mean, exactly. I mean, the glitters. You know that it has been supporting glitter, saying, hey, get glitters, get this. Guess what? I'm not recommending anymore get the AK11. I mean, the AK1H because so many people are having issues with it, including me. Brand new PCB, and I having problems. And in one occasion, shot the Chinese guy, you know, from glitter. He says, no, it's because it's not made for copper to copper. I mean, for welding copper nickel sandwich. And I says, what do you say? I mean, that is the reason, the main reason people are getting this. I mean, you're wrong. So, and they says, well, you know, then he changed the story. Maybe we have something there. I mean, again, it's not that many people that are having issues, but there's quite a few, including me, now with that PCB. Um, again, if you provide warranty, I have no problem. After the years, yes. After a year, you will have to cover that. You know, and that's not funny. I sell the PCB in the store. I'm running out of them. Actually, I'm waiting for more shipment. That's the problem. I mean, glitter takes forever to ship you something, and you know, again, it's difficult because I wish they provide a fast service when I email them because it's by email. It's in China. sometimes they take a week to respond an email. You know, when I have to make an order, and then you make the order, and then take like 3 weeks, 1 month to receive something, and it's frustrated. I mean, it's slow. I know it's a good product, but now AWIF, I mean, that's pretty quick. I mean, I hope again Glitter have the same service. I mean, that's why I'm exploring other welders, because the other thing is the Glitter is how we call it, brute force. It's a great welder, but it's not too many options. And for example, if you want to do dual pulse or preheat or stuff like that, that doesn't exist in the Glitter. It's so critical. It's so old school that you cannot control the seconds that it's gonna take in the automatic pulse. If you want to weld without the pedal, you can weld automatically, but you have half second only, and you have no way to change that timing in the Glitter. That's the ugly part. I don't like that, but it is what it is. Now in the new A-Width, oof, it have so many options that I really like in that welder. And well, I will see how good they are. To be honest with you, I mean, everything that I have been reading is excellent reviews. Again, except in the P120 that I that I beat the crap out of them. I mean, because again, if it's bad, it's bad. I'm not gonna lie. I'm not gonna lie. If it's bad, it's bad. Um, Talking about lie, and let me correct something. I says in the live that the EV, I says this is 5800 milliamps, right? It's not true. It's not true. Much actually, he quickly he texts me to tell me, hey, correct that. They are not. The minimum on this in data sheet is 5600 minimum. So they are rated for 5700. They say 58 there is, I mean, because they say 58, but they're 5700 based in data sheet. Still, it's an excellent capacity cell. And I tested this one versus the LG. This one gave me a little bit more than the LG, even when they are rated both of the same. Um, I have to clarify that because I don't want to give wrong information. Thank you, John Mush, for the correction. Um, Again, subscribe to the Patreon, man. Will you weld Molicel P50 diesel or the spot weld max a 0.3 nickel? How do you weld Molicel 50 PB cells in your spot where it can max out 0.3 pure nickel? Okay, first of all, I try to avoid welding 0.3 nickel because it's difficult to weld. I mean, it's not consistent. I mean, you really need to push the Glitter hard. I mean, the 811. I mean, if you have an 811, you can do that. You can weld 0.3, but you really need to crank her up, the Glitter, and I'm talking probably 80-90% power. And when you do that, you need to work with the copper first of all. You need to clean it first of all. It's not like the other one that I don't care. I weld like that and that's it. For 0.3, you need to clean the copper. And when I say clean, use alcohol and sand. You need to sand a little bit the copper to do that. In my case, I do not sand. Mark, man, nice, man. You have a base. You know what you got, buddy. I mean, the Glitter just is not sandwich well harder to do than nickel. Yes, it's because the copper make it difficult. The welding. Nickel with the 811. I guess you can weld. I never tried 0.5. I have here 0.4 and I can do 0.4 nickel. But here's the thing. To explain you something very important here. Many people go in a very thick nickel. Okay. For example, let me show you what I got here. I built this. Many people seen that before. I have here all my different thickness from nickel, from copper, This one is my personal one that I use sometimes, and sometimes it's not a secret. When I sell, I use from rolls. I mean, I keep everything in rolls. See, this is a very thick, wide, 15 millimeters. Uh, you know, I buy like that. Sorry for the mess. I have a big mess here. Let me see where are my rolls. Uh, let's see. See, that's 1 kilogram rolls. I'm talking this roll is like $100. In pure nickel. That's how I buy. I mean, in very big quantities. That's all this is copper. You name it, all kind of coppers I have here. Um, See different thickness. Even look at this. I use copper bars. This is a 3 millimeter copper bar. Actually, there should be two of them. What I do with that? Why I have that copper so wide? That's for bus bars. When you make a very big battery with and you need to connect the cables with, I mean, very fat screws. I'm talking when you weld with 0 gauge, 2 gauge, even 4 gauge cables. That's when I use using the connectors that I was trying to weld, showing you these connectors. This is for 4 gauge. I mean, this is very thick cables. So when you need to attach this to the bus bar, normally sometimes I bend, well, using how I do, I bend the copper to make it very, let me show you here. I show one before. When I make my bus bars, I don't want to solder in the bus bar. And there is a reason for that. When you solder, you can use the soldering iron and solder the cable on top. It's not because I don't have the equipment. I have plenty, really good soldering irons. It's because when you use the lead from the soldering iron, you introduce resistance. Why? The copper is very conductive. The soldering iron use, I mean, the combination of tin and other, I mean, components in the lead, and you introduce resistance. When you build something so nice, very conductive with copper, and then you messed it up with the soldering iron, with the lead. So what I mean is that's it's gonna be your weakest point. When you see this, for example, drawing, see that this is the bending that I'm talking about. See, I bent the copper few times, make it very tight, and then I can make holes and attach screws with the nuts connectors. So I attach copper to copper with a physical connection. That's your best connection. And if you don't believe me, ask an electrician how they do industrially, how the connection are made. They don't use lead. They don't solder. That is the best connection by rule is physical connections, and that's a physical connection. The one that you use with the screws attaching very strong. You have to make a strong bond. What's happening is when you try, the copper is a soft element, a soft component. So when you make too much pressure on this, you can end up bending a little bit. So I like to use those thick bus bars, right? Those thick bus bars. So I cut a piece of those bus bars, the 3 millimeters, and then I can loop the copper around and attach it, or I can spot weld copper to copper with the glitter, but I have to use the special flux. You have to do a lot of them, a lot of those connections, the copper to copper, to make sure you attach that weld to the bus bar. Then when you at the bus bar, because the bus bar is very strong, then you attach the screws to that bus bar. That's how you do it. To do a very nice connection. And again, I hate to use the soldering iron and connect, like, but with the small stuff, you have to do what you have to do. Let's see what this guy say. Kevin, it says, yeah, but as NASA star in their document, solder reduce the conductivity only when the two materials aren't touching. Yes, I mean, you can, and it's acceptable. Touch first the materials, and when you do that, listen, when you connect that, is you better sand a little bit. I mean, reduce a little bit the, I mean, to make it, the more that you sand the copper, and you can prove this with the IR gun, I mean, with the IR resistance. You know what, let me see something here, sorry. You make a better connection in that way. You sand a little bit, you attach copper to copper, very strong physical connection, make it tight. Even you can put the screw, and then on top of that, you can add the soldering, I mean, the lead, because the physical connection is first there, and then the lead, what it's gonna do is make sure that it's not gonna go out. Yes, that's a good way to do it. Even with the cables, the small cables, I like to use the connectors, with the terminals connectors. Make it first the physical connection, and then once you have that secure, and there is a physical connection between copper and the connector, then you can introduce the lead on top. Because your first connection is gonna be physical, so you're gonna have the benefit of that conductivity. So you don't introduce that conductivity. So again, you see this, what I'm talking about, more with a thermal camera. When you apply to those bus bars, 200 amps, for example, 150, 200. In the thermal camera, when you use the LED, uh, you can see the heat accumulation right in the LED. So that's your weakest point. So you don't want that next to the battery, because that heat is gonna transfer to the battery pack. You wanna get away from that. So by connecting again, the connections with physical connection, I mean, you don't see that. And I have few videos that you maybe can check in my channel, showing and demonstrating that. That's why as long as I can, I will use always physical connection. As long as the space allow me to do it, I ain't gonna use physical connection with the screws. So if I don't have choice, then I use lead. But again, sand first the copper, connect the cable to the copper first, and then you introduce the lead on top. I mean, that's the correct way to do it, to get the best connection. So with this very small cable, it doesn't matter. You pre-tin. Pre-tin is that you put first copper in the cable, then copper in the other, lead in the other connection, and then you join it. Yes, I mean, when you do, that's the correct way to solder. Uh, but at the same time, you don't do the physical connection first. I mean, I like to do physical connection first. So I have my techniques. Again, this is something that some people can challenge what I'm talking about. At least my soldiers doesn't fail, and thanks God, I check everything. They doesn't fail. I have a good technique. But again, I mean, some people can argue that, and hey, I'm not gonna argue with people that they are engineers, and I mean, a bunch of people I respect a lot. I mean, and again, we can disagree and be friends. I mean, it's like politics. You can be Republican, the other one. I mean, in the perfect world, that's how it's supposed to work. We are just friends. I mean, and I not necessarily we need to agree in stuff like that. I mean, again, I mean, each one, and I respect that, and but that doesn't make us, enemies. So, again, let me see how this is going. Look at that. That's how it's going. Let me show you the equipment. Information when the EV50PL come out for the public. Actually, talking about that, I forget. Thank you for reminding me that I have a bunch of people that already they put the the pre-order in the EB50PL. I have that coming. I have that coming. I hope it's gonna be here by the end of the month. I heard already that the ship that is coming from China is gonna go to the port on the 17th of this month. So and that's what, about a week from now. The thing is that the customs sometimes they stop the shipment for inspection. That's a lottery. Sometimes they do it, sometimes they don't do it. When they don't do it, I receive that very quickly. That I know the ship is gonna arrive the 17th to the port. They take like 3 days or so, like something like that, to empty the ship, and then if the custom decide to inspect that, they put it in a warehouse. Sometimes I seen up to 3 weeks in the warehouse waiting for the custom to inspect the items. Normally they don't take that long. I mean, sometimes they take it from 1 to 2 weeks, and then once they pass inspection, then they pass to UPS or FedEx, and then they ship that from California to Florida. I am in Florida. So and the shipment they take like 3 days or 4 days. I mean, from California to here, actually like 4 days. It takes. So that will depend when they're gonna arrive. That's why I mentioned that in the store when you check. It explained. I hope it's gonna be by the end or the first week of the next month. But they are coming. They are coming, and I have confirmation. The port is arriving to the port on the 17th. So which is next week, I believe. Yeah, 17 is, I guess, is Wednesday next week or Thursday next week, something like that. So I order 2,000 of those cells. I already have sold like probably 1,000 already. Because many people are waiting for this cell. And the other thing is that cell I try to buy more, and actually I bought what they have left. I mean, I bought that. I heard that, and this is information I haven't released. I heard that EB is gonna be releasing the actual production by the end of August, which is basically the same cell that I have, because they convert that from the samples, which is pre-production. Once the samples are good, they convert that in production. And essentially it's the same. I have a video from the. No, no, no. It's good, Kevin. Let me read what you says. How do you solder those cells? The moly cells are already too powerful for nickel, buddy. Moly cells, they're not that. I mean, they are okay. P50Bs, they are powerful. That's the most powerful moly cell. But I mean, any tabless is more powerful than moly cell. Any tabless is more powerful. I mean, there's no difference in the welding. It's the same procedure, except tabless. Let me explain that. Let me grab one. The different welding a tabless versus welding a regular cell, this is a EB 40PL, right? Look at the EB. Let me put it here. Do you see that center? They have like actually is a laser mark. Guess what? You need to stay away from that mark. When you weld, stay away from that mark. So in other words, you want to stay 3 millimeters away. So 1.5 this side, 1.5 the other side, and then you can weld in any place you want. Same, the positive doesn't matter. You can, I mean, stay obviously in the positive side. Don't go close to here because you're gonna short the battery. So tapless, you weld outside of that. Let me see if I can fix the focus. This focus. Let me put my cell phone here. Sorry for this. See if I can fix this focus. You can see better what I'm doing. Maybe. Let's see if that's. See? So now let me show you a JP40. This is a JP40. See, they have something similar. Now the exception is gonna be the back 45D. This is the back. All these three cells are tabless. But you still want to stay away from the center. You don't see it very well, but you see the little dot in the center. The back have that, but it's not that very visible. I don't know if you notice that. Let's see if I can focus that. It's just a little dot. Maybe there you can see it. So that's how they connect internally, the connections. So you need to stay away from the center. Now, there is another exception now, tabless, and it's, give me 1 second. Something that many people haven't seen it yet. I have the JP30 here. This is 18650. I have that coming to the store. This one is what is called LT version, but this is Ampes JP30. Now, look at how the JP30 is connected. This is different because, let me get a screwdriver to mark here. The JP30, the welding points are in the corners. Let me see if I can. There we go, much better. You see these marks here, here, and here. Well, guess what? In this cell, you need to stay away from that corners and try to concentrate in this area. We don't know yet if you can weld in the center. At least much open the JP30s. Go to the Patreon and you can see all this that I'm showing you. Much have that open. And apparently you can. But guess what? Because we are not 100% sure, you have plenty space around. Just don't go in the center. I mean, if you don't have to, go around and stay away from these three welds. That's how they connect the JP30. I mean, this cell again is going to be available, but this cell is just a beast. Check the numbers that Mush did already. I tested here. They claim to be a 36 amp cell, amps, but I tested all the way to 40, 45 amps, and it still performed. And guess what? Much tested to 60 amps and all the way even to 100 amps. This 18650, and it's performing. So what we believe the reason why they are not claiming more amps maybe is because the longevity. Maybe if you drain that high 60, it's just insane for the 18650. 60 amps maybe affect the longevity. We don't know that yet. We know that it does the 36 amps that they claim and way more than that, like eating a cake, like eating a candy. So when I say eating a candy, if we take, for example, an EV, we have an EV here, 30p, that is supposed to be 30 amps hour. It does 30 amps, but guess what? The EV sag at 30 amps. That's something, and the same with Molicel. Molicel, I guess I have here, let me see if what I got here. No, that's not 18650. This is P45B. I have the P50 as well. So to answer your question, you was asking how do you weld the P50s? So like a normal cell, let me find a P50. Where is my P50? Actually, this is the other 18650. This is the P30. And let me find the P50 for you. It should be here. I remember now what I put it. I was going to do something with those P50s. And I have a good news for people, the Molicel fanboys. Sorry, this is like Chevrolet or Ford. That's the P50Bs, right? They are not tabless. P50Bs are not tabless. So you can weld that in any way that you want. I mean, there's no difference. So now, don't get me wrong, this is an amazing cell, and we'll tell you why. This cell, different of any tabless, this cell can be discharged at 5C, which means there are 5 amps hour. It means you can charge. I'm sorry, you can charge this cell at 25 amps, charging one single cell, 25 amps. What means that? Buddy, that's excellent for EV vehicles. You can charge very quickly your batteries. A tabless cannot be charged more than 2C. So this one obviously 4 amps hour. 2C is gonna be 8 amps. Now think about it: 8 amps versus 25 amps. It's a game changer for EV vehicles. Now the goat I have here, one, that's the one that is coming. That's the king. That's the P50B, EV 50PL. This beast is rated for 125 amps discharging versus Molly cell. They claim what, 60? They claim it cannot do more than 45 continuously. Actually, I guess it cannot even do 45 because it's overheat. So, what strip do you use to deliver 120? Man, that's you just make an excellent question, buddy. You just make an excellent question. This I call this like in the racings, people call the Dino Kings. You know the Toyota Supra that they do. Toyota Supra, they can make 3,000 horsepower, 2,500 horsepower. Now the problem is put it on the floor. Put the horsepowers on the pavement, because it's gonna spin a lot. So that is what is happening with these kind of cells. So man, I have a mess here. To take advantage for the power that these cells produce, like the 50PL, you really are going to need copper nickel sandwich no matter what. You have to. There is no more choice. To produce all that power, let me put it in this way. To test these cells, I have to build a special tester. Let me show you something. Where is? I got it here. Damn. Sorry. Here. Man, that fell on top of the laptop. I hope it's safe. There you go. Right? Look at this, man. Just to test that cell, I have to build this. Because normally we don't have that. Look at these cables that I have to use. 6-gauge wires. 6-gauge wires. To be able to test that cell. This is rated for 100 amps, these clamps. 100 amps rated, because I was using first the regular ones that I use that are very heavy duty, and they was struggling. I mean, to pass all the current that this beast, because it's not. Let me explain. It's not only that it's 125 amps. It's that it's able to burst 180 amps. Guess what? I don't have equipment to test that high. I don't. So I send the cells to Dr. Bass. By the way, subscribe to his channel. I don't know if he's looking the video right now, Dr. Bass. He have a great channel. He's in our group in Facebook. If you haven't subscribed, go to the Facebook group. DIY 500 amp is the group. We are there every day, and we provide support and all that. So Dr. Bass is Steven in the group. Um, he have an excellent channel. So I sent that to him to test the cell and even to Mooch. Mooch tested it as well. I don't know if how far Mooch went in the testing. I don't remember. He went 180. I know Steven in a live, he tested to 160 and he just performed. I mean, the cell is a beast. This cell is just something else. So, but again, to take out all the power, you really need to use, I will says, copper minimum zero point 0.2 or higher. Zero point 0.2 or higher to take off the power of these cells. Now, how you do that? Because I explained, it's very hard to weld zero point 0.3. It's very hard. You can use, if you have a glitter, you can use the flux and you can do it, okay? Zero point 0.3, no problem. Now, the other way, you don't really have to weld straight zero point 0.3 to get that much, conductivity. You can weld zero point 0.2, one layer, and then put another layer of zero point 0.2 on top of it. And then you stack that, and then you have zero point 0.4. That's an excellent way to do it. That's completely fine. And then, of course, you're going to need copper, nickel, copper, nickel. And then you weld that on top of that. And that's how you weld, you are going to get zero point 0.4. Plus the nickel if you use the full strip. If not, you can use just pieces to do it. So this one, for example, is zero point 0.3. This is a very thick and difficult to weld. What I do to weld that easier, well, you can sand. In this case, this is not sand. Sand a little bit, just a little bit, to expose the copper. So you can use, I don't know, I have here to do it manually. Where is my, okay, there it is. Let me show you. You can use something like this for your copper, right? And then, scratch it just like this. And now, believe it or not, that is gonna give you a better conductivity. And not only conductivity, it's easier to weld on top of that. That's how you do it. My case, well, I'm cheating. I have a laser, and with the laser, I make make it nice. So you use the tool that you have. I have a laser. I cut this with laser, by the way. Nice cut. All that. This side doesn't look beauty, but this was a discarded busbar. Why? Because I damaged it. Welding. When you weld zero point 0.3, again, I weld this without flux. I don't use the flux for this. If I use the flux, it's way easier, way more stable. But I was not using it because I was expecting that, with the laser, I don't have to. And the other thing is, I was not having too much flux. I want to leave it for emergencies because that's, if the people know, that's very unavailable. Very unavailable. And until now, that again, for the people that just connect, I have that for sale now in the store in stock. Plenty of them. Look at that. And it's going to have the DIY 500 amp on it. That's the flux. I have 100 bottles here. It's a big box. So, yep, with that flux you can do it. And again, way cheaper than AliExpress. AliExpress have that like in $60 with shipping and all that. In the store, it's gonna be the flux in what, $18.95. Anyway, I don't wanna mention too many times the store. That's not my goal. Well, it's my business, but let me see what he says. I love Kevin. I love questions, buddy. Believe it or not. Sorry, another question. But when you spot weld copper on top of the other nickel strip, does not limit the current to pass? No, let me explain you. Because it's not gonna limit the current because the first connection is copper. You are gonna have the copper conductivity first, right? That's gonna be the first conductivity. And the other thing is when you fuse the copper with the nickel, let me see an example. One that is already fused. Let me put this back. When you fuse copper with nickel, and it's a bad example, it's actually not welded, they became one material, basically. So it's gonna pass by the copper. I mean the conductivity. When you put another layer on top, yes, the nickel is gonna touch first. So it's not gonna have the top one is not gonna have necessarily the same conductivity from the second one, but you still have a bunch of current available, a bunch, believe me, and you are gonna have a lot of conductivity as well from the first one. The idea of having the second layer is that still allow you to transfer current even if you don't have necessarily the 100% the IR from the first one, you still have a way more conductivity, and a more capacity to transfer all that current because you have then one on top of the other one. It's very important to spot weld as many times as you can. Let me put it in this way. Each spot weld from a regular welder, which is considered less than what, a 1 millimeter, it can carry, in theory, as a rule of thumb, 10 amps per weld, 10 amps. So that's why I recommend you go with at least 4 connection actually. I do 6 as more as I can. I do 6. So now, however, that is for regular dots like this one that are made with the Sunco small one. I mean, small tips. The glitter is different because the glitter have a very thick tips. I can show that. And so the tips, the connection from the glitter is very wide. Look at the difference. In here you can see it. Let me show you. This one was made with the Sunco. Let me get a pen. This one was made with the Sunco. Look at the size. And this is made by the glitter. Look at the hole. Actually, this is not a hole. It's an actual weld. Look at the size difference. So this connection, believe me, is going to carry way more current than this one. And this one is considered rated 10 amps per weld. This one, it does way more than that. So, and I put 6 of them when I weld, 6 of them. Yeah, that's a very bad example that I exploded doing 0.3. That happens sometimes. I mean, even to the best of the families, hey, we're not, see? Well, this one is because I pull it out and it leaves the copper on that, and that's good. You want that, actually. What you don't want is when this happens, when it explode the copper. And then you have to remove all the cells. Let me show you the fails when that happens. I may have cells here. See, that's examples. This cell is perfectly working right now, but because that happened, see, I probably went too much in the corner. That's bad. See, and that happened. So guess what? That cell, I took it out. It's perfectly working. I can clean it and use this for something else. Obviously, I don't sell this to a client in a client build. I keep them separately because I can do something for me if I have to. Man, I have a mess here. Talking about it. Talking and talking, I keep going, taking out stuff, and I have a mess. Yeah, so, buddy, that's how it works. That's how it works. So with your P50Bs, You just treat them like a completely regular cell. So you don't have to even be worried about the center. That's the P50Bs. You don't have to be worried about that. Now, what I was going to mention about the P50Bs that I mentioned, that I have good news for you. Next month, the P50B pricing is gonna go down drastically. And when I say drastically, it's gonna be, I believe it's gonna be in the $5 or $4 range. And when I say four, it's four high. Why? Because the P50PL is coming. There's no way this cell can compete with the 50PL in the high performance, area. No way. The only that this cell shines, honestly, the moly cells is two things. It can be charged very fast at 5C, and the other one is, yep, cycle life. And the cycle life is one. And the other one that people doesn't know, this cell can be charged at negative 40 degrees. Negative 40 degrees can be charged this cell. So you can use this in the winter. And the tablets, they can be charged at negative 20, not negative 40 like this one. This one can do negative 40. That's something that we need to mention in Molicel, that this really shine. But again, what segment of people take advantage of that? Well, in my opinion, at least for what we do, not too many. Not too many. Yeah, probably for the EV vehicles, it's gonna be great, great, great. So you can do quick charge. However, we need to mention quick charge goes against love 10 of them. I bought $15 each. Buddy, don't wait, don't buy that yet. Wait for next month. It's gonna go really cheap. Really cheap next month. This sale. And anyway, I'm not gonna buy that cell when you can buy this one for almost a little bit more money. Just a little bit more money. Check the pricing that I have in the website. I got it already. You can pre-order this cell. I have about right now. I still have like 1,000 that I can. I mean, they don't. They are not pre-ordered. From the 2,000, I sold already like 1,000 of them. They are in pre-order, so they are compromised. But yeah, man, yeah, no, that's crazy. By the beginning of the year, these cells, you remember, that was in $10 each. $10. These molly cells. And well, I refuse to buy them because it's too much money, man. Oh man, no, but forget about bad cell. Bad cell, you know how bad cell is. They rewrap cells. I mean, in their brand, it's like the Bapsel, the 4100, the N. Which one is N4100? Basically, you are buying an EV40PL. That's what they're doing. They're rewrapping the EV40PL, and they sell it as a 4100 milliamps because everybody knows the EV40PL give you 41, almost 4100 milliamps. I mean, it depends. I mean, some of them they can give you 4050, like that. But they Bapsel that T41. I believe you confirmed the model. I don't know. Yeah, it's a 40PL rewrap. Anyway, man. Well, I have been talking about a bunch of topics here. Where do you see the negative 40 and the 5C charge? I don't have that data in Molicel. Let me show you. Many people doesn't have the where I got it. I got, if I don't recall, the full data sheet. That's something that many people doesn't have from the. Let me see if I can find this live here. Data sheets. Let's see. Molicel P50. Oh, guess what? I don't have the P50B here. I have data sheets here. I don't have the one from the P50B. See, this is a full data sheets. Normally, people doesn't have this. But that's the P45B. Oh, I don't have the P50B here. See, this is the short version. That's the what people have. This is the short version of the data sheets. That's what normally people have. But the long version, this is a short version too. This one is the long version. Yeah, this one is the long version. I'm gonna share these data sheets in my for my members. When I say members in YouTube, uh, well, now I have a layer of memberships, and I have actually, I guess, Reigns is one. Actually, visit his YouTube channel. Let me show you this here, man. I should show that here. He have a great YouTube channel, but here, that's visit this channel. Yep, this is his channel. He's a young fella that have a very interesting videos, and not only that, he's really good. Let me show you an example how he.
Hey guys, just a quick video to let you know that I'm going to be attending the SMCBA and Associated Electronics Expo this year
He's
in
going
Melbourne,
to,
Australia,
you
from
know,
the 6th of May to the
events
8th
and
of
all
May.
that.
For those who don't know about the SMCBA conference, it's a collection of really informative presentations related to circuit board design and quality
Look at
manufacturing and
that.
testing
He have
of
really
production.
good, I mean, way to
For
present
more
the channel
information,
and all
head over to
that. Way better, better than me. I mean,
smcba.asn.au/conference because if you sign
he's
up
a
now,
pro
thanks to my
in
YouTube
that. I
channel
mean,
in your registration and select the payoff line option, SMCBA has kindly decided to waive the
yep, man, that's his channel. I invite you. I'm gonna actually send me. Yeah, I'm gonna put it in the comments your channel so that people can subscribe to your channel. So, and the other one is Patreon. Go to Patreon and subscribe to Much. This is the last thing that he was posting. I don't want to present necessarily the topics because I mean you need to see. I'm passing very quickly, very quickly. So from battery much, that's cool watts. Let me put battery. That's much. So that's the membership. You can get at $3. I choose to have 20. I pay $20 in my membership. I mean, to help much because I know. I mean, the testing that take a lot of money. But look at the topics. He does very. Let me go quickly. I don't want to show the contents, but look at that. Talking about the, I mean, very see the testing and going quickly. Hey, pay those $3 and subscribe to the channel. Look at the testings. I mean, he have so much. I mean, to offer. I'm not gonna show more. Um, but buddy, subscribe to my channel. And to answer your question, where do we see the 5C? Uh, it wasn't in a data sheet. I have the data sheet somewhere. I have to find out. But yes, it's 5C. And actually, check it much. If you go to the Facebook group, uh, that part is public. You can see that information as well. Much have that information from the P50B. I mean, again, it's a great sale. Uh, in my opinion, there's not too much difference between in performance from the P50B from the P45B. I mean, in performance, there's not too much difference. I mean, yes, it's more powerful, but it's not for too much. Yeah, the benefit, yeah, I have a little bit more, little bit, and I don't say a lot more. Um Watts hours. In fact, believe me or not, the check it out. We double check with much, but the back 45D and the and the Molicel P50B, I believe they are tight. And the back 45D is 4 point. Well, now they claim 4.4. In reality, I know they give all the way for 4.5. But here's is something that I wanted to mention. Why these numbers keep going changing, and I want to talk about that now. That's a very good topic. Why does number keep going changing? Why I have a bag that says, look at this, something I'm gonna show you. Why I have a bag that say 4.5 amps hour, and why I have a brand new bag You know, Web, I haven't opened. I guess I don't have one open. Let's see if I have one open. Anyway, the brand new one is say 4.4 amps hour. It's the same cell. It's exactly the same cell. What's happened is when this cell came out, if you notice, this cell do not have the CCC information. The CCC logo, which is, let me see, one cell with the CCC information. I guess this one have it. No, this one doesn't have it yet. I know this one have it already. The 40PL has it. See that CE and these three CCC here? Guess what? All the cells now, they have to have that. All the cells, they have to have that. That's a Chinese regulation. Well, mandate, they have to have that logo, and they have to have the CE is the European one from Europe. So, and what's happening is part of the regulation mandate that you need to print the lowest, absolutely the lowest amps hour than your lowest cell will offer. So they produce sometimes B grade cells. I mean, or cell that doesn't meet the 4.5. And because of that, and that's maybe a 5% of the cells. And I don't buy that, by the way. They have to print the lowest number, the lowest they have to print, and legally. So not legally, but by regulation, they have to print the lowest. Now they have to lower from 4.5, they have to lower that to 4.4, but essentially it's the same cell. The cell actually, depending the group that you get, let me teach you that now. In the bags, it's by groups. The AO1, AO1, AO2, AO3, and AO4. AO4 is the one that I buy. Because the 804, we know, can give you 36 amps hour. And let me see where it say it. And somewhere it's gonna say it. Let me show you where it is. That's millivolts. They put it in the box somewhere here. There it is. You see where it says 45 to 46 amps hour. Let me see, maybe another box have that more clear. Look at that. These batches, they have between 4560 to 46 milliamps. And that's only when you buy the AO4s. So that's the cells. That's the cell that I get. They're a little bit more expensive. They're a little bit more difficult to get, but they are 4.6 amps hour. We know tested they are 4.6, almost, or exceed. Actually, I sent you too much. Much tested even more than 4.6. I guess he went to 4.68 or 4.6 something. I don't remember. Is Much is there? Much? How much you got? I don't know if you are online. Let me check if Much is online. I cannot see the names. Can someone confirm if Much is here? It should say Battery Much or John Mushu. Anyway, that's the one that I get. I mean, I take advantage because I study batteries a lot and I know what I buy. So I mean, when you believe me, when you get my batteries, I bring the best that I can, the best. I mean, and I test my batteries, and I offer the best. So that's the one that I get, the AO4s, to get the best bags. So those bags, they give you the same or more. No, you don't see it. No, he's not. I know he was watching because he sent me a message in the first live. Probably he's not in this one. So I divide the live in two. I don't know why it's divided in two, but yeah. I mean, with the P50Bs, the back 45D deliver more the same or more amps, no amps hour, watt hours, then that's what you should be getting, watts hour. And that's how you want to buy yourselves, based in watts hour. Forget about capacity, about that's more marketing. So check how many watts hour can really deliver the cell. That's what you need to see. And again, right now nothing is better than tablets. First one, the king right now is the 50 PL. And the second one, in my opinion, I mean, it's between the back 45D. I mean, because offers you a really good capacity and with really good power. But in power delivery, I mean, the JP40, it's really, really good. 40 PL is right there behind JP40. By the way, check Mooch 100 amps shutout. The JP40 in 100 amps shut out. It basically he discharged the cells in 100 amps, even when they are not rated for that, because I mean, again, don't do that at home. He's a professional. He know what he was doing, and man, I need new glasses. I'm getting old. Um, Check it out. The JP40 was unable to finish the test because it was triggering the my goodness, the valve that disconnect the cell. I mean, the cells have like an internal valve. I mean, on top of the cell, on the positive side, they have that is triggered by pressure. When the cell internally make too much pressure, that release that valve and it disconnect the cell to protect the cell from a runaway. And many people doesn't know this, but a cell that is doesn't give you any voltage, it can be perfectly fine inside. I mean, when that trigger is for something, I mean, it's not because it's good, but sometimes you can get a screwdriver in between, trigger that back and connect that back. I should not say this because I don't want you to do it, but it's just telling you that it's possible. You take a screwdriver in between, you push it back, and then you reconnect the cell, and then you can reuse the cell technically. I don't recommend that because when that trigger is for something and is for a protection, But how and it happened to me in one occasion that I opened a cell that is supposed to be in discharged because I short the cell for 1 week to make sure it was not having any power before opening the cell. And when I opened the cell, I seen a spark. Man, that scared me. When I checked the voltage, I was having the full voltage, 3.8 volts, and I opened the cell with a Dremel. So, in other words, it was a miracle the cell doesn't caught in fire. I mean, because it was perfectly fine inside. So that's why it's very, very critical. Know when you open a cell. I mean, I don't recommend open a cell. I mean, don't do that. Leave that to the pros. I mean, even I'm not a pro. Mooch is a pro. I mean, Steven is a pro. I mean, I'm just a good aficionado, with that does a lot of testing. I don't consider myself a pro because I know what takes. I mean, to be a pro. Oh my God! I mean, there's a lot of things that I still need to learn. I mean, that this guy knows, and I really respect the work that they do. Um, I'm working every day to get there. Soon, I mean, I'm gonna get there. I mean, hopefully, uh, and I'm putting a lot of effort on that. So, and again, well, let me show you. Some people doesn't. Let me show you my setup. I mean, 3D printer. I have my Ender. This is an Ender 5 Max. This Ender allow you to print 400 by 400 millimeters. There is a very big bed. Look at what I'm doing right now. That's a big tray. And I did even bigger trays because not only if you have more than 400, you still can do it because you can put it in angle. and you can print. Now, when I have to do a really big projects, I use this one. This one is 420 by 420 by 500 height. The height, I don't care because in battery, what I do is trace. But this one is any cubic Cobra 3 Max. This one is 420 by 420. It's a beast. And not only that, this printer allow me to do colors. So I have this, which let me see if I can open this. Look at that. I can put different colors or the same material, and then when one filament runs out, it keep going with the next one if they are the same, of course. If they are the same. Right now I have PG, I have PETG, I have ABS. You know, I build the batteries with ABS. So I have that one. I have as well my K1 Max. This one is a really good printer. But if you see the bed is 300 by 300, which is big. Don't get me wrong. It's just the other one are just beast. That's the K1. I use this a lot, and doesn't do colors. For colors, I have to do it manually, just like the Ender. That one does automatically. So really good printer. I recommend that printer for whoever is starting. Get this is a beast, and I believe they cost right now like $800. When I bought it, it was 1,200. And but now my next printer that I'm gonna be buying, I'm between the Bamboo H2H or the K2, which is 350 millimeters, but it's enclosed. However, I just bought, it's coming, the enclosure for this printer. There's an enclosure that I'm gonna close it just like that from Creality, and it's gonna go all the way high. And I order as well the bed for this printer. I'm gonna replace this bed with a full aluminum, solid aluminum, and the heater is gonna be more powerful. It's gonna heat up more the bed, and I'm gonna be changing the power supply. It have a 500 watts power supply. I'm gonna be putting a 1,000 watts power supply in that baby. Yeah. The other side, that's the laser. Many people, I don't know, people have seen it. That's where I cut copper. So I have that attached to the computer. I design here, make the design, and then I go here and cut it. You know, I'm gonna be making a video demonstrating how the laser works for the what does the enclosure? That's a good question. The enclosure is important because when you print filaments like ABS require a very heat environment to be able to attach that's ABS. Correct, the heat. I need more heat to be able to attach ABS. And the problem is right now I'm printing ABS, but sometimes it came loose, and when they came loose, it bent in the corners. It bent, and that led to happen this. You see all these failures. All this that you see is lost material because when they became loose. Let me show you one. Look at this. That's what happened. So this, I mean, it still work. I haven't trashed it because I still can use it for if I cut it for another project. But look at what happened. Let's see another one. This is another failure. Let me put it here so I can use the other hand. You see it? That happened because we don't have enough heat to maintain the material. That doesn't happen with this printer because this printer can maintain the heat inside contained. So that's why the enclosure is important. And this printer doesn't come with the enclosure, but I bought the enclosure separate, which costs like 200 something dollars to contain the heat. And also, again, this bed goes only to 100 degrees, which is for ABS, and why we need to print in ABS. ABS is the material that I use for the batteries because that material can support more heat. It's more heat resistant, so it's important for the batteries. So because it's not gonna deform the tray if the battery heat up. So if I use another material like PLA or yeah, mostly PLAs is the easiest material to print. But again, the PLA is gonna bend with a little bit of heat. When I say little bit, with 80 degrees, it starts deforming 80 degrees. And a battery, can go with 80 degrees when they heat up really hard. They can go to 80 degrees. So I don't use PLA. Again, the most stronger material is ASA, which it give you like 10 more degrees higher than ABS. And ABS is acceptable. But I like to use sometimes ASA. Is this the more expensive as well? I use ASA in that printer, in the small one. But the problem is the small one. I'm doing big projects sometimes, and I cannot print. I like to print in one piece. I can print few pieces and join it together, but I don't like. I don't want to do it because it's not the same quality. You have to use glue, then you have to. No, I mean I like to print in one piece. That's why I bought those big printers to offer the best quality possible. I mean, again, get your good tool. You're gonna be as good as your tools. I mean, and I believe me, I'm not making money. I'm not making money. I'm putting everything in the business, everything, getting the best of my tools, the best. So once I got the tools, once I have all the inventory, once I have everything, then I'm gonna put me a salary. But for the moment, see, I get my best tools, my welders. This costs like $700 each of these ones. This one is the very. I mean, with this beast, this welder, I can solder zero gauge with this. It's a beast. So I have another one. This is the 120. It uses the same machine, and I have the really small one. This one is for the very small welds. This is 90 watts, but this is industrial quality. Again, get the best equipment you can. I mean, that's what I always says. I mean, very good chargers. I have this beast here. I don't know if you guys ever seen this charger. This one can do 16 in series, 16 cells in series in dual channel. That's a serious computer charger. I mean, same as this one is, it can do 12. The iCharger, and the iCharger not only do that. The iCharger is the one that you can use for cycling batteries. You may sometimes you think how much he tests the longevity in the batteries, right? What is longevity? You discharge and charge, discharge and charge. How many times? So, well, some batteries are rated to for 1,000. 1,000. Is the 20S charger available anywhere? Buddy, I'm in contact with the people of ISDT, that brand. They says, actually, talking about ISDT, I have another ISDT. Look at the small one that I have. I'm charging right now some AAA's. They are working in a 24X. It's gonna be for 24S. Once that is released, they told me that they are gonna use me as a tester. So they are gonna be sending me one with those chargers when they are ready for me to test. but I'm gonna use it personal, man, because that charger is gonna be a beast. 24, buddy. Basically, you're gonna be able to build a pack without BMS, just with the BMS cables, just like the airplane packs that we built, and charge the batteries and balance with the charger. So it's gonna act like the BMS for the charging part and balancing part. Of course, I mean you don't have BMS, you don't have any protection when you're using the battery. I don't recommend that. Don't bypass BMSs. Some people does it. They know what they are doing. I mean, they know. Well, I do it with the airplanes. I mean, we don't have in the lipos. We don't in the airplane. You don't have BMS. You don't use that. You monitor the with telemetry. That will be awesome because 72 volts apply to a lot of applications. Yeah, man, 72. That's 20, and the charger is gonna be 24s. 24s, like the battery, the last one that I built. You guys, I haven't posted that in YouTube. I built. No, I don't. I haven't posted. I posted in Facebook, but I built a very big pack. Well, not very big. It was a big pack. 24s 12p with JP40s. Actually, those bus bars that you seen that I destroy, basically, it was from that pack. It was from that pack that I built. It took me 2 weeks and a half to, and I was working very hard to build that pack, completely custom. It was 24s, so 84 volts nominal battery, fully charged was 108, I guess, something like that, volts, which is you don't want to make a mistake in 100 volts. I mean that's oof. I mean, I don't want to even think about it. I mean, shorting. You can lose a finger. I mean, or a hand. I seen. You have to see the picture. I seen from people shorting battery that powerful. Yeah, you don't want to make a mistake. Actually, more than 50 watts is considered high voltage in DC. I mean, that's a high voltage. So imagine in 100. Oof, I don't want to even think about it. But anyway, yeah, man, there is not a single charger that I know, smart charger more than 16s like that one that I have. Again, I'm waiting until they release that because nobody else have that. I mean, and I really want to have a charger like that for those builds that I do sometimes. So, yeah, will EV or 50 JP30? Let me see. But I know 50, the EV50PL is gonna be available. I don't know in the Australia market if someone is gonna bring that. I guess this guy can do something. Well, I'm gonna talk to him later. You know, to bring that to Australia. The JP50, I do not know even when it's gonna be released. And I'm honest with you, I know it's their same. Well, I released some information in the membership post, which is from back. Back is coming with a back 60. Back is coming with a back 50, 50D, 60D, and I believe there in the roadmap there was something in the, I don't know if it was 70D, but I know there was working with something in the 70 department for 7 amps hour. Same with Molicel. Molicel is working with in that range, that high. When they're gonna be released, I don't know. I mean, I don't know. I mean, and even with the 50PL, I mentioned, I don't know, like 2 months ago, and that now I know they're gonna be released. My understanding is by the end of August, and this is why they're not gonna be available now. This batch that I'm gonna have, as soon as that's sold, it is what it is. We're not gonna have 50PLs until probably by the end of September, because if they release that and by the end of August, I buy that immediately by the end of August, and that takes about 5 weeks to I receive that, because I don't buy that by airplane, because I mean in airplane I can have that in week and a half, but the cost is gonna be so high. Can I ask you how the glitter flux works? Uh, I explained it in the beginning of this video, but of course, yeah, I can show you what you have to do. Basically, it's apply a literally one, what is considered one drop. That little, just a little bit touch um, between. If you are gonna weld to the battery, you put it that on top of the battery, just a little bit, just a little bit. You don't want to mess, just a little touch, and then you put the copper on top, and then you put the nickel, you know, and then you weld, and that's really is gonna boost your ability to weld thicker copper. If you are doing copper to copper, which that's mostly what I'm gonna, I use that for copper to copper. You put between the two copper sheets or the copper, not only sheets, I mean the copper terminal. Look at what, that's what I use a lot there, because I was trying with a 0.4 millimeter, and actually attached but not strong with the 0.4. Probably if I crank more and if I sand this and I sand the other copper, clean it up very clean, then put it back, probably I can do 0.4. I can do 0.4 with the glitter. It's just that I skip those procedures. I mean, but I mean, I don't have interest to do it at the moment. 0.3 is good enough for me. But again, you use that between copper and copper. Yes, put just one drop, one drop. You know, and when you weld, you're gonna see a lot of smoke coming out. That's normal, but that is very strong. It's very strong. I demonstrate in the video here, attaching two 0.3 together. Let me see where I put it. Where I put it. These two ones. That was 0.3 or 0.4. I guess that was 0.4. I can't remember. Two togethers. I cannot take it. Separate that. Look at that. Using the flux. Without the flux, they don't attach, and I test that many times. They don't attach with the flux. That really boosts the ability to weld together. And I'm very happy, and I'm honestly, because I mean the price that the Chinese they put, that was completely abused. That was a very abused. My last one I sold that for $25, and that was before the tariff. $25 in the store, and then they skyrocket. Right now, check it out. Now they're a little bit cheaper in AliExpress, and they're still in the $70, $58, I guess. And what I did, and I know that was not easy. Find who was the factory, and I talked to them, and I says, hey, I really wanna bring this for an affordable price. And then they put me a minimum purchase amount, which was a minimum for 100 units. I have to buy, otherwise they don't sell that to me. So I bought the 100 units of them to get a good pricing, and now I'm able to sell it in 18.95 and on the store, which is cheaper than what AliExpress had it in the beginning. I guess the cheapest one was like $20, $15 plus shipping. I mean, at the end, I pretty much match it or make it better price. So, but again, I have to buy 100 units. I have a lot of money in that box. So, but I hope that lasts me a little bit, and the people, support me. And I know they're gonna do it because nobody else has did. You cannot find that in Amazon. You cannot find. Google it. Google it. You're not gonna find that product nowhere. Nowhere. So, and it's because the minimum amount that you have to buy is too high. It's 100. Is a lot of money. That's over $1,000 in investments. So, and I have to buy that to provide that. I mean, again, my business is DIY, 500M DIY. So I wanna, the difference from my store, I sell sales and all that, but I wanna bring you the what you need to build by yourself. And that's one of the things that you need. I mean, I wanna bring you the copper, I wanna bring you the spot welders, anything that you need to do it yourself. That's That's my difference from other stores. The other store, they just want to make sales, sell sales, make money from that, and they don't care if you can do it or not. You don't have material. They don't care. I mean, I care. I mean, I want to bring you the spot welder. I want to bring you all the material, everything you need. I mean, even I want to offer the uh, if you need something like this, you cannot find this anywhere, and I have the ability to make it. I'm gonna sell it. I mean, I take time. Look at that. I'm making one right now. In all this time, I'm still printing. This take hours. So again, it's electricity, it's material. Sometimes doesn't go well. You see, I lost a lot of material. So we need to charge for that. Unfortunately, I mean, because it's time and it's material. I lost a lot of material sometimes, and I lost that money. It's a lot of material that I lost to make it perfect. And I wanna when I sell something, I'm gonna sell a good product. You know, believe me, that this it's gonna be like that. But anyway, I don't wanna sound like a seller at this point. So I wanna bring you content. You know, we was talking about the glitters. I show you how to open this. I mean, almost to change the PCB. It's just a few more screws, and then you take out the PCB. You put the new one. You need to weld that corner in that MOSFET. You need to connect that cable plus the other four cables in the other side. These four cables, and that's it. That's how you change the PCB in the glitter. Put it back, and you have a new PCB working. So yeah, some people are gonna say, yeah, but I don't know how to do this part. Yep, it's a learning curve. It's a learning curve, especially for those small connectors. You need the tools. You need a small soldering iron. You need to remove the one of the that's a nice one. I don't know if I haven't show you my desoldering gun, which is my Draco. Let me show you this tool. The Haco. For me, this is a most to have. I mean, if you are working every day, get one of these. I mean, this gun allowed you to remove any soldering, and it's electric. When you press this, it have a pump that suction like a vacuum cleaner, and then you can suck all the soldering and clean a PCB very nicely. So yeah, for those little connector, I use this to remove that. Man, I would love. Let me show you how that works. Let's do it now. Let's do it now. I have to do it anyway. You're gonna love this tool, man. You're gonna love it. How that works. It's again, it's expensive. You get what you pay. Come on, let me fix this. Sorry, I'm trying to fix this cell phone mount. It just came bad apparently. Yep, it just came bad. We have to do it in another way now. Wow, it just came bad. I need a new one. Anyway, let me show you how that works, because it works beautiful. I'm connecting this now. Come on. There we go. I guess it's connected. Let me see. I don't know if it went all the way in. No, it's not connected. Let me take out the other one. There we go. Now it's connected. Right now it's heating up. Right now. Let me put this here. And I'm gonna show you how cool is this. It's like a normal welding machine that is heating up that end. Let me wait a little bit more. Look at how cool it's gonna be this. You see this cable that I have to take it out? All I have to do is present. Let me zoom a little bit so you can see it better. I mean, the mount came bad. You see that? Look at what it does. The tool just you present that here, just touching, and look at this. The cable came out automatically. Very easy, just like that. I don't want to do another one because I don't remember the layout right now out of my head and I have to do it. But if I have to do another PCB, let me see anything else that I have here that I can show you. What PCB I have here that I can work with. Um, or a connector. Ah, that's a good one. Let me find a connector to show you with a connector. It's on right now. Ah, I have one here. Sorry about that. That's a bad example, I guess. But anyway. For example, I want to take out these ones that are big, right? Look at how big they are. If I need to take out something like that, then I just touch this here. Look at this. Touch it, just like that. Look at that. Touch it here. And just like that, almost, this is tough. This is tough to, let me touch the corner first to make sure. It's almost done. This is I'm sorry. I'm not showing this. Man, I show you a bad example. See? That's how you get that. This is very tough to take out normally. And this tool, look at that. It take all the solder that easy. So, and it put it in that tank. So that's how it works. That tool is just incredible. Really good. That heat up very quickly. So I just took out that, you know, uh, from that PCB. I have to fix that converter, so I don't care taking out the parts. But that's how I change capacitors or anything that is by welding. If I have to clean a cable, a connector with this utility, I mean, you get what you pay. I mean, this, I don't know the price. I believe it's in the $300 range. This is made in the US. Actually, it's a USA tool. Let me show you here so you can see what it is. Yeah, I bought it 2024-11. That was last year. By the end of the year, made in Japan, but this is American tool. See, US patent. So it's a really, really, really good tool. I really recommend this to anybody. Um, Let me put it back here. I joke, your mom is gonna appreciate that tool. I don't know the Latin. I mean, anyway, I'm not going there, but yeah, uh, the tool is gonna prevent you. I mean, a lot of angriness. I mean, because sometimes removing stuff like that, especially the big parts, just like that. Oh my God, forget the name of that. It's hard, very hard to do, and with that tool is piece of cake. For me, it's piece of cake. Even when you have to remove a connector that you have with the cable, I clean that very fast with that tool and leave everything easy to do. I mean, and then before that, I used to use there's like a copper strip, like a braided copper roll that you have to use to clean out the lead from the top of the electronics. There is a lot of copper. I mean, you need to keep going using that. I mean, with that tool, you do everything. I mean, very fast, very fast. Anyway, hey, get the best tool you can, because when you buy good tools, you buy it only once. That's my slogan, and I put a lot of money. I mean, in the tools that I have. I don't have a salary. I don't put a salary on myself. I don't. I mean, I have my other job that many people know. I don't want to make it public, but I have my main job that I'm in for 20 years. That I'm working hard. This store a lot. I mean, I'm working very hard to try to make it as my main income. I'm not there yet, honestly. I don't have a salary. I'm putting everything in equipment, printers, laser tools, very very good tools, and inventory. I investing everything in inventory. The sales that is very expensive. Imagine and buy 2,000, 5,000